looks like we've made it to the phase shift. Phase shift, not simple. Requires a little bit more. Yeah, so know this. You only have a couple problems in your homework, but you'll probably be tested on the phase shift. I typically like to, I care about the 5 little tick marks that you end up getting. So let's dive into this. Take a look. And this is a slide I had this up from before. Except I had the bottom part kind of canceled out so you can see it. So we're going to be looking at y is equal to a times sine of b times x minus c. And that's the argument, bx minus c. Argument. Not like you're mad or anything, it's just the name of it. Like the stuff that's inside the parentheses is called the argument. We're all speaking the same language. We'll be talking about these two forms. Let's ignore D for right now. There's certainly some fun games we can play with D. But for right now, we're focusing on moving left and right much more. We're going to focus more on this, smashing, moving, and really all of our x's. So I'm going to keep the amplitude today, here on this one. I'm going to keep the amplitude at 1 as well, just to keep everything mellow. So we're just going to be talking about the period and what we call the phase shift. Well, let's define the phase shift a little bit. The phase shift. And I have to miswrite for the way that I explain it. I kind of call it like the start. It's the start. Now, there's no start to a sine or a cosine, right? Sine, cosine, go on. Look at my shitty thing. But it goes on forever. The point is there's little arrows and it just does it, and my graph's totally off. But there's no start. When we're speaking about like start, it would be, well, there's the sine wave. Now we know that it continues on. There's all kinds of other fun stuff. But we think that right here at x equals 0 is our typical start. Right? That's where we would start our first period. So we're talking about a phase shift. Would mean, what if this thing got pushed down? What if it got pushed down by some amount, right? Well, whatever the x value would be, that's the phase shift. How far did it get pushed down? Now, if the phase shift's negative, that means you're going back that way. Okay, it's just telling you the x value, but it's what x is equal to. And I'm just going to pop it in and say that x is equal to c over b. That's going to be your starting point, wherever you start. Cool? Cool. I'll prove it to you throughout this little the left and right endpoint thing. That's what we're talking about, where we're saying the left endpoint. Our left endpoint. Our right endpoint. Where do those two things end up? Cool. Now we're also going to have something else, and let me misspeak again. So I'm going to call it our end, or the right endpoint. And let's think logically about what this would be. Well, it's going to be wherever you start, so the phase shift. I'm going to write it in as PS, again, phase shift. But whatever our period was from before, right? Don't we have the same period, but now it's just shifted down? So if we want to know what our, and when we're talking about this, we're always talking about the x values. We want to know what x is here. Well, we're saying that x is going to be equal to the phase shift. This little area here, that phase shift, plus the period. And that's going to be the ending point. So I want you to kind of understand what it is and why it all ends up there. So if you don't catch this, and maybe just catch the algebra later. Cool. But this is the what's happening more than anything else. So here we go. Let's use the formulas that they've given us so we can show that we have the same thing. So this is going to be like our start, or the phase shift. That's where we're going to find it. So let's take it down and take a peek at it. So we say that bx minus c is equal to 0. So we do algebra. We're trying to solve for x. So we add c to both sides. So we get bx is equal to c. Now we divide by b on both sides, and we get that x is equal to c over b. Chill. Chill. C over b. Now, that's cool. I told you that was going to be our starting point, our phase shift from up above. plus the period. And here's where it says we're going to get our right endpoint is going to be right here. That bx minus c is equal to 2 pi. So let's do the same thing. Let's do a little bit of algebra to it. So bx minus c is equal to 2 pi. So we're going to add the c over, just like we did before. It's all the same process. 2 pi plus c. And just like back here, we divided by b. We're going to divide by b again. Let's put it on both. And we get that x is equal to 2 pi b plus c over b. But wait a second, isn't addition commutative? So we get c plus b, c over b plus 2b, or 2 pi over b. So that's saying this is where we end at? This is where we end at, c over b plus 2 pi over b. Do you know what 2 pi over b equals? That's the period. So I've just shown you that this can be your endpoint in just b's, c's, and 2 pi's. So we have our two different formulas. Let's make sure that we know these two things. For our phase shift, we're going to start at x is equal to c over b. And we will end when x is equal to c over b plus 2 pi divided by b. So there's the two parts where it's just going to show you that this point right here, x is equal to c over b. This point here, this x that we found, that end point, that's going to be c over b plus 2 pi over b. And I know it seems like a lot, but you just got to get your practice with it. Just like anything, you start to get more accustomed to it. So let's do a problem. Let's make it simple. Let's not get crazy. Let's just say y is equal to cosine of, and let's just put a 2 in there, 2x minus pi. About as simple as we can make it right there. So let's just define some stuff right away. Because there's a couple ways we can solve for this to be able to get a quick little graph out of it. First one, I think we should really just go through and be like, all right, b is equal to 2, and c, that's equal to pi, not negative pi. The formula that we have, our general formula, has a minus sign in here. Don't lose sight of that. There's a minus sign, not a plus sign. Sign error is a killer, dude. Sign error is a killer. So careful with it, huh? So now that we have our b and our c, we're like, well, dude, let's go find where we start. We're going to start, big quotes, at the phase shift. So that's x is equal to c over b. So we're like, I got this. C is equal to, oh, we're going to start at x is equal to pi over 2. All right, that's fair. That's fair. Now where are we going to end? Where's that end point? Where are we going to end at? And we're like, well, that's it. X is equal to c over b. Oh, where we start. Actually, I'm going to put that. I want that in blue. Where we start plus what's the period? So let's go find the period. The period is 2 pi over b. Our b is 2, so our period is equal to 2 pi over 2 from right there. But what's that equal? Pi. Right? They just cancel out. The period is equal to pi. So x is equal to, oh, why did we take the 2's away? Look at that. Why would I take those 2's away when I could have just left them there and create the common denominator? I just wasn't looking ahead. So it looks like we're going to end when x is equal to 3 pi over 2. So we'll start our phase shift at x is equal to pi over 2, but we're going to have the same shape. Nothing's going to change. If you know how to graph cosine, we're going to be able to graph this thing. No issue whatsoever. Now that we're here, we just kind of look in, and we're like, well, we're going to start at x is equal to pi over 2. So, I don't know, call that pi over 2. We'll call this one pi. Make the gaps pi over 2, and then we get 3 pi over 2. I'm just kind of thinking of the unit circle, because I recognize both of those. And then you get 5 pi over 2. Okay, cool. Now just let's make this a 1 and make this one a -1. Now I know what cosine looks like as it starts at the beginning. It starts right on the y-axis. That's where cosine starts. But now we have our phase shift. this phase shift telling us, oh, we don't start up top anymore on there. We have to shift it over by pi over 2. We got to shift that thing right on over by pi over 2. So now cosine for y is 2x minus pi. We start right here. And now we're going to end at 3 pi over 2. Now you see what I've done? I've made a horrible mistake. I can't, I need to zoom in. Look at how I made my scale. My scale sucks. My scale sucks. Now I have to find something in between because we need to be able to recognize these points right here. When we graph, we need to know that we're going to cut this all into 4 equal pieces, where you start and where you end. There are 4 quadrants. 1, 2, 3. So you got 1, 2, 3, and 4 quadrants. You got to break it up. So you could find the length and divide it by 2 and be like, hey, the period is pi over. The period is pi. But if you want to know how to break it into 4 pieces, divide it by 4. And you know that you just go up by pi over 4. So pi over 2 plus pi over 4 is 3 pi over 4. Pi over 4 plus 3 pi over 4 is 5 pi, or 4 pi over 4. 4 pi over 4 plus pi over 4 is 5 pi over 4. Now we found our intercepts. Just by using a little bit of logic. And we know we just keep working right in like this. So, not simple, huh? Now this would have to go back, and wow, that looks like something else. That looks like negative cosine. So sometimes these will look like something else. Shit. To me, I think that's the same thing as y is equal to negative cosine of 2x. I think that's the same thing. But whatever. So you don't actually have to graph these yourself. You just have to be able to read them. So you want to know where's your max values at? Where's your minimum values at? Where's your intercepts at? This is going to be the key to you being able to read that shit and being able to answer these freaking questions. So it's all about this little phase shift. Memorize your C's and B's. Write it down. Do something. I don't give a shit. But make sure that you know how to do it because you're going to get tested on the phase shift. It's freaking weird, but a little bit of practice, I think it pops out. Bother your past peer about this. If you have questions, they know it's coming. All right.